All right, 22 and 23. Population has a mean mu, population mean, equals 53, and standard deviation sigma equals 14. Find the z-score for a population value of 29. So if we're trying to identify the z-score, we can use the z-score formula. Z equals the x value minus the mean divided by the standard deviation. X value is your value, the specific value that you're referring to in the data set. Mu is the mean, population mean. Sigma is the population standard deviation. And Z is the z-score. So we're just substituting these values in. My x value is 29 minus my mean, 53, over sigma, 14. So Z equals 29 minus 53. That's negative, what's that, 24 over 14. We want to express this as a decimal. So let's divide here, negative 24 divided by 14. That's negative 1.71. And we want this to two decimal places, negative 1.71. That's our z-score for a population value of 29. So if x equals 29, the z value equals negative 1.71. They're equivalent. I think I said 1.79, but it's negative 1.71. I'm not sure. I'll look back at this video and see what I said. Same idea for number 24. Same formula, rather. But this problem says which number has a z-score of negative 1.4. So in this problem, we're using the same formula, right? Z equals x minus mu divided by the standard deviation divided by sigma. But in this case, we have, let me erase that, getting ahead of myself. We have the mean, mu, we have sigma, which is 4, and we have Z, which is negative 1.4. Now we're trying to find the population value. We're trying to find X. So we know Z is negative 1.4. We don't know X. We know the mean is 26. And we know sigma, the standard deviation, is 4. So we're trying to solve for X in this case. So I think we should cross multiply. X minus 26 equals negative 1.4 times 4. Scroll down a little bit. So x minus 26 equals negative 5.6. I will add 26 here. Add 26. Right? So x equals 26. Negative 5.6 plus 26. Which should give me 20.4. Right, 20.4. Yep, that's what that is. So my x value here is 20.4. That equates to a z value of negative 1.4. A little bit less than 1.5 standard deviations below the mean.